Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the year-end summative. It's question number 8. The question says, the height in meters of a point on a boat's propeller relative to the surface of the water is defined by, and then there's an equation here with h for height as a function of theta, an angle, is negative 0.12 times sine of theta plus 90 minus 0.43, where theta is the angle measured in degrees. So we have an equation with sine as the basic function. And then what we have to do with that equation, we need to find the maximum and minimum depths of the propeller and determine the depth at a few given angles and explain the results. So first, let's make sure we understand the question clearly. We have a boat's propeller. So here's an image of a boat. It's in the water. And here's the propeller. It's that thing that spins, which is attached to a motor that makes it spin. So here's a better kind of zoomed in version of a propeller. And so we're supposed to study a point on the boat's propeller. So I put this red dot here to indicate a point. So as the propeller spins, you can see that that point is also going to move around and around in a circle. So if we move it a little more slowly, and if you watch what's happening to the red point, you can see that it will basically rotate and trace a circle. So that point is effectively tracing a circle, and there will be a minimum point when it's at the lowest part of the propeller spin, and there will be a maximum point, and every point it reaches to just repeats and repeats as the propeller spins. And what we have in this question is information that the point, or a point, I've just highlighted any point I picked, can be studied by looking at this equation, and it's studied with reference to what angle it has spun through. So what we're going to be measuring is the height of that point compared to where the water is. So just like in my diagram, generally a propeller should be under the water. So, the water edge will be here, so we're going to be below the water at some point. So that's what we're doing. We're studying the height of that point on the propeller in relation to the surface of the water. So let's look a little more carefully at the first part of the question. It says, what would be the maximum and minimum depths of the propeller? Okay, so let's first study this from sort of a fundamentals perspective. We know that what we have here is a sine function that has been transformed. So let's think about what we know about sine functions. It doesn't matter what the angle is. We know that sine of any angle, so any angle, has a maximum and a minimum. No matter what, I cannot get bigger than 1 with sine, and I cannot get smaller than -1. Now, you should know that from having hopefully done enough trig and sine questions in your math career. But let me just remind you of why this must be true, because sine fundamentally is defined as the opposite side length over the hypotenuse sine length in a right-angled triangle. So if this is where my angle is, here's opposite and hypotenuse. Now, since that's the very definition of sine, comparing the opposite side to the hypotenuse in a right-angled triangle, now we just have to add the fact that we know that the hypotenuse is always the longest side in a right-angled triangle. And what that means is that the denominator of this fraction will always be bigger than the numerator. So we'll always have, when we set up our sine ratio, a fraction where there is a small number divided by a bigger number. And there's no way to make that bigger than 1, like 6 over 7. Oh, can I make it bigger? I could make it 11 over 12. I could make it 999 over 1,000. But because I always have to make the denominator bigger, it's the hypotenuse, remember, it's impossible to write a fraction where the denominator is bigger, but the fraction is somehow equal to greater than 1. So we know that sine of any angle has a maximum of 1 and a minimum of -1. So that's fundamentally important for understanding the maximum and minimum of a sine question. So let me just clean up some of this mess I've left all over the place. So we know that the sine part of this function has a maximum of 1 and a minimum of -1. And so we're going to use that information to find the maximum of this function and the minimum of this function. So what are we doing to that sine value? So once we find whatever sine is, let's say that we have the maximum value, which is 1. So this sine theta plus 90, no matter what theta is, has a maximum of 1. Which means that when I then multiply it by negative 0.2, I will have a new maximum of negative 0.12, and then I need to do minus 0.43, and that gives me a value of negative 0.55. Now, one thing to note is that because I multiplied my maximum by a negative, I actually just turned it into a minimum. But even if you forget that, you'll notice that it will be the minimum. It's definitely either maximum or minimum. So let's kind of follow that logic and talk about the minimum. We know that the minimum value for sine theta plus 90, we know that the minimum is negative 1. So what happens to the rest of the values if we were to sub negative 1 for this value? Well, I would multiply by negative 0.12. So negative 0.12 times the minimum of negative 1 is 0.12. And then I have to subtract negative 0.43, which gives me a value of negative 0.21. Now, that is actually the maximum. Again, because I multiplied my minimum by a negative, it actually turned into a maximum because it flipped upside down, basically. So knowing what we know about the basic sine function, we don't have to memorize things because we know that the minimum and maximum of any sine function are 1 and negative 1. And therefore, my maximum value is this one because it's a bigger number. And my minimum is negative 0.55. So those are the maximum and minimum depths. So again, if you think about the water line, here's the propeller, that as it's spinning, it will never get above negative 0.21 meters, and it will never be below negative 0.55 meters. Now, I'm going to answer this question again because I also want to show you how you could simply memorize some facts and get this answer. So let me just clean this up. I do think it's much more important to understand why the answer is what we just have than to memorize, but sometimes memorization is good too. So this is a transformed sine function. So if you remember, and I'll use h theta here, we have a sine k theta minus c plus d. Now, you may not have, been a while. I hope you still use minus c here, but it doesn't really matter. All of the stuff that's in here relates to the actual sine of the angle. So that's the stuff that just, changes what the angle is that I'm about to take sine of. So no matter what, within this red box, we'll only ever see values between 1 and negative 1. And then we're transforming all of the values we get between negative 1 and 1 through multiplication by a and addition of d. So that's a transformed sine function. Now, so no matter what I have, my minimum and maximum can be found by taking negative 1 times a and adding d, negative 1 and positive 1 times a and adding d. Another way to think about it is, this is the way actually I like to think about it, is that whenever I see a sine function, so let me just reset here. I know I'm giving you multiple approaches to this, but I think that it's important that you latch onto and remember the approach that just makes the most sense to you. I don't think it's a good idea to just straight up memorize. It's always better to understand. So here's what I know. I know that the normal sine function is centered at 0 and goes to a maximum of 1 and a minimum of negative 1. And it kind of looks like this, but we don't even need to know that. Now, because of a d value existing, this 0 has been moved down to negative 0.43. So this value here, the d value at the end of the function, tells you how that normal sine function has been transformed up, or in this case, down. Now, normally the amplitude is 1, but my amplitude is actually whatever that a value is. So I'm going to ignore the negative. Remember, all the negative actually does in terms of my function is it makes me graph it upside down like this. It doesn't change where minimum and maximum values, what they are. So the 0.12 is my new amplitude. So from negative 0.43, I need to go down by 0.12, and I need to go up by 0.12. So if I go up by 0.12, I'm at a value of negative 0.21, and if I go down by 0.12, I'm at a value of negative 0.55. So this is how, if you were in my class, we tend to do it like this, where we say, well, where is the middle line? And then look at your amplitude and go up by that much and down by that much. You'll get the exact same minimums and maximums as what I originally did, but now you can probably get them algebraically and mathematically faster, but I think it's important to see why that's true based on the extreme values of sine. Okay, so we answered the first question several times. Let's move on to the second part. It says, determine the depth of the given point on the propeller after rotations of 240 degrees and 600 degrees. So this is simply telling me an angle. So let me just rewrite the equation. So, and minus 0.43. Okay, so that's the equation we're working with. So what it's giving me is it's giving me an angle. It's telling me that theta is 240 degrees. So I have to substitute in 240 degrees for theta and then just calculate an answer. So if I sub in 240 degrees plus 90 degrees, so that's the only substitution I have to make. And now I just take out my calculator and do the math. So following order of operations, I need to calculate what that new angle is. So sine of 240 plus 90, that's 330. And then making sure I'm in degree mode. If I take sine 330, I get a value of negative 0.5. Now I need to multiply because that says subtract, and you do that last. So multiply negative 0.12 times negative 0.5. What do I get? 0.6. And then finally I'm going to subtract negative 0.43 from that, and I get negative 0.37. So at an angle of 240 degrees, the height of the propeller is negative 0.37 meters. So again, that means it's below the water surface by 0.37 of a meter. So then the second part of the question says, do it again, but this time for 600 degrees. So I'm going to follow this exact same approach, but sub in 600 instead of 240. So we're going to now sub 600 in. So this time theta is 600. And again, once I sub it in, I just do the math. So 600 plus 90 is 690. And if I type that into my calculator, sine 690 degrees, oh, it's also negative 0.5. So I'm going to finish the math, but if you remember from before, that's the exact same sine ratio we had. Oops. So we should get the same answer. So here I get 0.6, and then I get negative 0.37. So we know that at 600 degrees, h equals negative 0.37. So when it says explain the results, I think it's asking us, explain how could we get the same answer for two different angles? Well, here's what we know. We know that 240 degrees is exactly 360 degrees from 600. So, and 360 degrees is one full circle, or to use a little better vocabulary, one full revolution between 240 and 600. So if we think about a circle, and if you want, think about the propeller in this circle, the point that I put maybe here, if I rotate it by 360 degrees, I'm back to where I started from. So 240 degrees and 600 degrees are at the same height because they're exactly one rotation away. I'll say one full turn away, because I think it's better to explain in my own language and not use, funny math terms. So that's, I believe, what they're looking for when they say explain your answer, is that how did we get the same answer for both? Well, we had to get the same answer because they're exactly 360 degrees, which is one full revolution, one full turn. If you want to be very fancy, you could say one full period away. Ooh. A period is the amount of time it takes for a sine curve to do this. So anything that's a full period away, so for example, this point is a full period away from this point because it's exactly returned to where it is in that sine pattern. Anyway, I probably went on too long, but if you're here to learn, I thought I'd help you learn. I hope that helps. Make sure you're doing as many questions as you can and getting as much help as you need. Thanks for watching.